not at a place I had hoped I would be or wanted to be by this stage in this project, but it is what it is, and got to face reality. The flyback transformer in this television, this 1968 MAGNAVOX color television, is testing bad. So I've got to get into it and hope to find a usable part number, since this is not the original flyback. And I also want to thoroughly inspect it and hope that just maybe we might find a repairable problem. It's not impossible, that sometimes happens. But the first step is going to have to be getting all of this unmounted from the chassis and tracing all of this circuit out. Since I do not have data on this, I'm going to have to do a full wiring diagram on everything I remove as I remove this, just to get in here and see if maybe, just maybe, this will be a repairable problem. And I'm not holding out a lot of hope for that. Chances are very favorable that this is going to be a failed flyback transformer, which will just have to be replaced. Let me go ahead and remove the high voltage rectifier tube. .3A3, the gathering on it's still looking good. It'll need to be tested, but it's not gone to air, so that's good. And now we finally got our first kind of decent look at the flyback down in here, our first decent glimpse of it. So I might as well get started. I want to discover once and for all what this smoke component is here. I'm thinking it's a smoked boost rectifier diode, but I might be wrong. There are other boost circuits that have the boost voltage tapped directly from the damper circuit, so it might not have a boost rectifier, and without service data, I don't know until I investigate this further whether that's what it is or not. Welcome to Brooks Hobby Shop, y'all, and this is some of what we get into when we launch into trying to restore these old televisions. This might be the last video I get out before Christmas, so to those who celebrate, Merry Christmas, and to everyone, hope you all have a healthy and happy holiday season. And I'm going to go ahead and just start. First thing I've got to do is carefully diagram all of these connections, and then I'll set about to unsoldering these, and we'll go ahead and see what we find here. All right, here we are. Just a brief moment for y'all, but a couple of hours for me, tracing all this out as best I can. And I'm having a Doc Emmett Brown moment here, like I usually do on my diagrams. Please excuse the crudity of this model this diagram. I didn't have time to build it, draw it to scale. I didn't have time to draw it to scale, Marty. Okay, poking and prodding around while I was doing this, I have found another definitely bad part here. 66 million ohms, 20%, and it is opened as a barn door. That is this resistor right here. And I'm afraid this might be, like the Flyback, a little bit problematic to come across nowadays, because these resistors are special. They are not replaceable with any standard carbon comp or wire wound resistors, because these resistors are rated for high voltage. This one is probably rated for 6,000 volts at least, and that would very quickly arc through and destroy any regular carbon comp or carbon film or wire wound resistor. They have to be specially built to handle that kind of voltage. You don't even have a watt rating on these. They don't have watt ratings. They've got voltage ratings. So this was, until it failed, a 66 million ohm, 66 meg ohm, we'll say 6,000 volt resistor. So that might be another potential stumbling block in the restoration of this television. But anyway, and this arrangement right here is looking kind of dodgy to me more and more. I don't think MAGNAVOX arranged this. We got a 3 million ohm resistor right here, and they're series together. And I just don't believe MAGNAVOX did that, where, you know, when you open the high voltage cage, it could even come close to striking all of that, you see. So I'm thinking I've uncovered a mod from a previous servicer here too. I think originally this resistor was down below the level of the lid for the Faraday cage, just running from here to here. Once again, using the data from this 1968 Sylvania, if we come over here to the Flyback for that one, here's that resistor right here, R169, 66 meg ohms at 6,000 volts, connected to the cathode of the focus rectifier. Alright, if we come over here to the parts list for that Sylvania, you'll see right here, R169, 66 meg ohms, 6,000 volts, and no watt reading stated. Got the wattage listed for all of these others, but right here, just 66 meg ohms, 6,000 volts. These are special purpose resistors, y'all. So it is now added to the list of the growing list of everything I need to obtain for this television. I've got to obtain data for it. I've got to obtain a Flyback transformer, almost definitely. And now I've got to obtain this. So, let's go ahead and get this thing out of here and hope for the best. Okay, we're going to start just by going ahead and disconnecting the filament leads from the high voltage rectifier. That'll be easy to do, easier with all of this still mounted. How are y'all doing? I could use some good news right along now. Things are trying to pile up here. since I'm now convinced that's a service mod that I uncovered on that resistor, I think we are probably about to start really discovering some of the history of this television. At least its history in its final hours. Alright, that came off of there entirely too easily, so that in itself pretty well indicates that this has been worked on before and is definitely a replacement flyback. The fact that I found a service modification is sort of calling into question in my mind now, as much as I try to fight it, whether or not this is even really the correct replacement transformer that this television has in it. Why would somebody pull a modification and add an additional 3 million ohm resistor if the replacement flyback used in this was originally like a, you know, a recommended replacement. Come on, get off of there. Yeah, I could just cut them, but oh, look at there, look at there. That's beautiful. It just keeps on piling up, y'all. The heat from the soldering iron pulled the terminal through the high voltage rectifier tube socket. All right. When it rains, it pours. My. You know, actually, I don't even see the full remains of the terminal. I do not even see the full remains of the terminal anywhere. So, it looks like a previous servicer already got into trouble on this, and I noticed this one was really kind of, you know, like soldered damn close right in there. So that's something that should have been repaired back then. I'm not going to really worry about that. I can, of course, that can be repaired, but yeah, I don't even see the remains of the terminal there. Wow. We just keep hoping against hope until we know the full story. I'm hoping that just maybe, since this television had so much rat and roach damage, that maybe I'll find wires chewed into or corrosion accounting for that open circuit. But like I said, you know, pretty well probably hoping against hope on that, but until we know for sure, we just keep trying. It's not full-on officially bad until it is so bad till replacement is not even an option. I mean, until saving it's not even an option. Boy. Definite replacement transformer. MAGNAVOX would have never left it where these wires would disconnect so easily. Oh yeah. I'm going to take that as my little bonus right now. That whatever other problems we have, at least it's coming out easily enough. Ooh, there went a solder splash. I ought not to be getting into a hurry on this. That right there looks a little bit dodgy to me too. It's wow, and it's got the insulation actually damaged a little bit there. And I can never remember to keep this sucker cocked when I'm on camera. Oh, come on. Yeah, come on, shaky hands. Do your thing. All right. I better suck some of that up or I'll end up with a solder splash going down into that circuit board. Probably got enough lead length to go ahead and get it all off of there without even unsoldering and trying to preserve the lead length. But you don't want to cut these wires, y'all. Electrical tape, standard electrical tape and heat shrink tubing does not really stand a chance against the kind of voltages that are present in these circuits. So you don't want to have to splice these wires. You won't just go ahead and unsolder them, get them out of the way. If nothing else, I'll take this as an opportunity to go ahead and start the chassis cleanup on a television that is getting a growing number of things going against it. Oh, you come on off of there. There we go. There we go. Clean it all up later. I was worried actually in a previous video when I discovered I had broken this 3 million ohm resistor loose up here. But I'm thinking probably when I do get the data on this television, we're going to find that MAGNAVOX never even used this sucker right here anyway. got a spark gap right here in the focus circuit, and it's got another spark gap up here in the socket. So MAGNAVOX took an extra measure on that. There went a solder splash. Alright, I see where it went. It landed right there on that electrolytic that's going to have to be replaced anyway. Did he do the lazy thing and just touch that in? Alright, that's good. That's good. At least that's making it easier for me. Go ahead and pull this on up and out, I think. Or did he actually wrap that? Nope. Nope, nope, nope. Take advantage of the previous servicer's laziness where you can. Generally, I don't, I like to have terminals more secure than this when I solder, but since I'm planning to actually still try against all odds a power up on this chassis eventually, even with this flyback, I'll end up doing some tack work too on this before it's over. But yeah, I don't generally. He might have actually wrapped that one. That would make sense to wrap the one that's up here in the hardest to access location. I think he did. Yeah, he did. Doggone, he actually wrapped one, or, oh, you know what that is? That's the lead to our smoke component back there. That is the lead to our smoked component back there. All right. Live action YouTube. Always check behind yourself when you do soldering work. Don't ever be so proud and sure of yourself that you neglect to do that. Got a big solder splash right here I created. Right there beside that resistor, and you see it's almost bridging circuits if it's not. Got another tiny little splash right there. Got some right here on the top of that little electrolytic capacitor. I'm going to have to make sure all of this is cleaned out before I apply any power to this. And that right there is thoroughly stuck, so always check behind yourself. I wonder if this is actually a gap cap, combination capacitor and spark gap, because here on the pitch tube socket, we've already got the focus lead coming in right here, and then this wire coming out, this one right here, right next to it. That was connecting to ground right there. So we've got a spark gap in the focus circuit, at least on right here in the socket. And to have that, And then this component right here being just a spark gap is a little too redundant to be believable. So I'm suspecting there's a capacitor actually inside of this as well. Anyway, let's go ahead and see if we can... Oh boy, come on. Oh, there we go, there we go. Get the mounting nuts for the flyback out. This one down here, I bet it's tightened up just as good as... Nope, it broke loose too. Okay, so I've already got the wires from on the filament of the high voltage rectifier. Got them pulled through in here. And now the flyback is loose and ready to come out. So I had to do some examining on this because my plan was just to take the full Faraday cage and everything off the chassis. But right here, we've got this filter capacitor, and MAGNAVOX put a screw holding the Faraday cage right here behind that capacitor. So by the time that screw is backed out, it's going to butt right up against that capacitor. So I don't believe they designed it where you had to take this, unsolder and take this whole capacitor out. So we have to look for other provisions, and we noticed that the side panel right here on the high voltage cage is actually loose. And if we look right there, it looks like some sealant, but I believe that's actually wax from the original flyback in this television. And it looks like we had a screw right here and another one up here. In fact, definitely it had a screw here and here. And then we don't see a sign of a screw here, but we got a brad right here. So I'm hoping that this is the service provision to access the flyback in this television, that if I just get right here and I pull up, and there we are, y'all. Made to service. There's our access to the flyback transformer. So if we needed any more evidence that it is not, that this is actually a replacement, as soon as I work her out of here, which is easier said than done, especially on camera. I'll have to do that on camera. I think I've got it all loose back here, but yeah, we can already see wax down in here where the original flyback basically had a meltdown. Alright, let me see what I can do here. I can get it off on the edge of the table and just go ahead and fold that down. Oh honey, will you come on out now? There we are. For whatever we're about to find. A quick note, I'm going to clean this beeswax and all out of here, and I always save this stuff. It comes in very handy to use as a sealant on other flybacks and other components in a television. It's got a very high dielectric strength. So when you're cleaning out stuff like this, I'm of the ilk that likes to just put it all in a bag and just save it. Because it's that kind of material that if you're looking for the dielectric strength that this would have had, you got to be kind of careful when you're shopping for it. So sorry for the shaky vision, but okay. Let's go ahead and get this sucker right here where we can get a good look at it. Well, 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 where do I begin? Oh boy. Well, I'll begin right here. Our smoked component turned out not to be a component at all. That turned out to be a lead extension from the coil capsule. It looks like if we look at the point where it's spliced, that lead was extended to exit the terminal board here, whereas originally, if we look at the length of it where it's spliced, it looks like it was originally measured to exit here. Okay, on the terminal side, that would be that it was moved from here to here. So instantly we've got a modded flyback. Okay. We do have a part number, D-406F, or alternately 17-7820. These numbers would most closely correspond to Triad or Merit as far as the brand of this. Some Thordarson. It might be a Thordarson, but I feel like it's one of those three. And my plan was, if I found a number, to go ahead and start shopping for a new flyback transformer for this television. But we've got a modded flyback. Alright, it gets worse. This sucker was installed entirely wrong. The television could never ever have played at all the way this transformer was hooked up in it. So once again, and this happens, and it is the second time since I've collected in this area that I have come across a television that somebody just went hog wild trying to mod and swap connections all around in. But the good news is we may have a good flyback. We may have a good flyback. As it was connected in the television, though, it could never ever have worked. It failed the plate-to-plate test because the plate lead from the cap of the horizontal output tube was connecting right here, and that terminal has a P beside it, which to all the world, including me, while it was installed in the chassis, denoted plate. Alright, well, if we turn the transformer around and we look, here we have the plate cap for the high voltage rectifier coming out up here at the top of the coil capsule, just like it should. And then, if we look below it, our high voltage secondary comes out right here and does not run to this terminal. Instead, it runs up here to that terminal, which is labeled S. Alright, when I measured from plate to plate, we got a reading of better than 900,000 ohms, close to 1,000,000 ohms. Well, that would be because the way this was connected in the television, with the horizontal output plate connecting here and the actual high voltage secondary connecting here, we've got a freaking RC network with a 820,000 ohm resistor in series with the plate of the horizontal output tube. That corresponds to absolutely no tube type high voltage supply I have ever seen in my entire life. And other people out there who have worked on them, I'm sure it does not correspond to anything you've ever seen. So these are probably original components to the TV, just put back in totally the wrong place. And with the plate cap of the horizontal output tube connecting here and having 820,000 ohms between it and the high voltage secondary of the transformer, it could flat out never have worked. The television could never have played even once with this arrangement. All right, but there's good news, maybe. But let me hold off on that. It looked like we had a component here, which I was thinking was maybe the boost rectifier diode, but there is no component, just a lead extension. You see we've actually got two leads, two really fine leads here, twisted together. So there's actually two circuits in the transformer exiting there. So, and it originally, again, will probably run through right here. What looked to be a melted down plastic housing turns out to be dried and set high voltage putty, a material I've used many times myself. But it was this and a little bit of wire insulation and a big huge chunk of spaghetti right down here at the coil capsule of the Flyback. Alright, they also had high voltage putty very noticeably while it was in the television when we removed it, wrapped around the lead to the high voltage rectifier. Okay, if you can see, if my camera will quit blurring and focus on this with it fighting to find what I'm wanting it to focus on. That's burned. If I can get the camera on it. That's burned. The lead to the high voltage rectifier plate had arced through this insulation to something, and maybe it arced through and was arcing to this lead right here, and therefore they decided to move it from right here to up here. I still have not the first clue where all of this burn mark came from. But the good news is when I was doing the plate-to-plate check on this transformer, and it failed it in flying colors. Once again, I've got my meter set to the times 100 ohm range. We'll be using the top scale on the meter as before. And if I connect here, where the actual high voltage secondary from the horizontal plate cap obviously is supposed to begin, to the plate of the high voltage rectifier, I'm going to do a short here to show y'all my meters calibrated. I'm just going to short right here, and there we are. I wish my camera would quit blurring. I don't know why my camera is just insisting on blurring everything today. Come on, come on. There we go, there we go. All right, well, anyway, I am now going to once again check the continuity from the plate of the horizontal output tube where it should have connected to the plate of the high voltage rectifier. And we're showing 400 ohms, which is excellently within range of what we would hope to see. Right at 400 ohms. So it actually turns out that our high voltage secondary in this transformer is healthy as a horse. But the horizontal output circuit in this chassis has unfortunately been heavily modded. I had already determined that the addition of this 3 million ohm resistor right here, which might still be an original part, just somebody moved it to another location. But this is a circuit mod. MAGNAVOX did not do this. I am now convinced that our 66 meg ohm, probably hard to find nowadays resistor, which is still bad, it was zapped and burned out by just totally haywire circuit modifications in this television. All right. It appears at the moment, like if this is a good compatible flyback with this chassis, that this flyback transformer is actually still good. That's the good news. But this right here, which struck me as sketchy as heck to begin with, because I noticed there's an RC network that was right there in the circuit of the plate. Even if this had been the plate lead, you don't generally see this on the plate lead of a horizontal output tube. But again, working without data for this specific chassis, you know, I just accepted it as you know, the way it was supposed to be. But we now know that this television has had some serious screwing around done with it. My entire diagram here for the way this flyback was connected inside this television is now basically, other than being a point of reference, out the window. It'll probably be next year before I obtain service data for this television. So I'm at a bit of a standstill. If anybody can help me out on some of this, some way, somehow. Once again, we're working on a MAGNAVOX T92408AB chassis. And the AB, I could not find in Sam's. I could find every suffix except AB, but this is probably a late production, especially considering that it's listed here on this label as Run 2. This is the Howard W. Sam's data that I am convinced covers this television, set 956-folder 2. Well, yeah, set 956 folder 2. But it was wired in just totally effing wrong. This calls into question whether or not this, even though the terminal board matches the cutout in the Faraday cage and all exactly, this basically means we've got a genuine MAGNAVOX type terminal board on the Flyback. The fact that a lead was moved makes me have to wonder if this is the original transformer, though, for this terminal board. Sometimes, and I have in the past, years ago, done it myself, I have swapped transformers from, that I modded in from their original terminal boards to the original terminal boards that were in those televisions. So I thought I was the only one in the world that ever did that. But I've got to entertain the possibility that now maybe somebody else has tried that trick as well. And then, unlike me, just hooked everything back up in just any old fashion, like they were just looking like, going by wire memory or whatever, just like oh, this wire looks like it probably connected here. This wire looks like it probably connected there. Well, it don't matter as long as it's all hooked up somewhere, it'll work. So, I mean, there's limitless possibilities to what happened here. I wonder if the television ever played with this transformer to begin with. Or if all this modding, it could not have played with this transformer if all this modding was done when this transformer was installed. It could not have ever actually played one time with this transformer if all of this modding was done when this transformer was installed. Possibility that the transformer was installed and originally installed right, and it did originally work and worked well with this television, and then at a later date somebody else worked on it and just, pulled all of this doggone crap. It was already striking me strange that just, using other manuals for other televisions, which I'm generally able to do when something is, still factory wired and wired properly. I've, used manuals for other televisions many times trying to, and I've used it successfully before, similar circuits between different brands and models, but I've done that before many times, but probably I'm going to have to get exact data on this one now, which I intended to do anyway, but I was hoping maybe, to limp it back into basic operation at least, before doing that. On the Flyback, I guess I'm happy that it may be a good Flyback if it survived these service mods, these screw-ups in the way it's connected, because possibly we had the plate of the horizontal output being connected to the damper circuit in this Flyback, the way it was wired in here. Our focus rectifier which normally connects right into directly into the plate lead of the horizontal output tube, was not connected anywhere near that. So obviously all of this is screwed up as it can be as well. I've got to reform my original hypotheses again on this television. This television's life ended, I am convinced, with it being taken to a poor quality servicer, and then the owners probably got some line of bull shot at them, like, well, it's got a bad picture tube, it's beyond repair, oh, we can't get parts for that anymore. And so the owners came and picked it up, took it home, and just put it into storage after that, and never found anybody else to work on it. They probably tried to, and then considering that might have well been in the 80s or maybe even the earlier 90s, they probably just could not find any shop anywhere that would even, take it in. So, when I was talking about finding a repairable problem, this is not what I had in mind. This is not what I had in mind at all. And there is, again, this is the second television from this area of Georgia I have found that has just had somebody go crazy with unworkable circuit mods. I posted a video on the other one. It's the 1956 Olympic 21-inch black and white that even with data for that television, I, to this day, have not successfully unraveled it. I do intend to get back to it because it is a real nice 1956 Olympic 21-inch black and white pedestal model with its original pedestal. But somebody had just gone into it kind of like this with the theory of, just swap wires around and, don't pay any attention to its original design. Just stick everything back where you think it ought to be. Possibly this might have been a good flyback, and it might now be damaged because some of these modifications would have certainly, if it had power applied to it for any length of time, would have stood an excellent chance of cooking coils in this, cooking some of the lower secondaries. So it appears to have continuity, but I'm going to have to check it a lot further. And I'm going to have to get back to y'all and just kind of end this video here. I'd get into a multi-hour video if I start trying to untangle all of this. Maybe in this television it won't be as bad as that 1956 Olympic. You'll find that video I did on that where I was just pulling all the parts I put into that sucker back out because it finally beat me, and I had data on that. This one appears that it's all right here in the flyback stage. I haven't seen any sign of this chassis where, thankfully it doesn't look like they went through the whole chassis doing this. It looks like it's all right here. But I can't really go any further right now, and I thought it'd be cool if maybe, since this television apparently came off the line back in January of '69, if it could be ready in time for New Year's, and it could start its new life, a television that was at least inspected, if not manufactured, in January of '69. It could, even if it's just playing kind of half-ass, it could begin its new life, and this restoration, ringing in 2026, that we might have actually had a watch party and, watch the ball drop on this sucker. I'd allow myself to dream that far, but that's all pretty well out the window now. But I am going to, even without specific data for this, there's basic rules that these circuits have to follow. And I'm going to consult other manuals for other televisions, and I'm going to try to piece all this back together the way it appears to me that it ought to be, and the way it appears to most other manufacturers, the way, you know, it ought to be. I'm going to do that. I'm going to try to get this Flyback thoroughly, because it's not art. We don't have any art marks on this coil at all. It is it's like new quality clean. No burn throughs or anything anywhere. I'm going to try to get it all back together, and I'm going to have to try to diagram this transformer as best I can, and get its general topography diagrammed, and then I'll flip back and forth between manuals for other televisions in the meantime, and see if you know, we can piece it back together like that, and maybe still have this thing kind of working in time for New Year's, maybe. But in the meantime, this will be my last video before Christmas, so y'all have a very happy, healthy, and joyous holiday season. Wishing the very best to you all. Thank you all so much for your interest in this project, and for watching and subscribing here. And be good as you always are, and just, you know, have a wonderful week and holiday. And I'll get back to y'all on this just as soon as I have something more concrete to report. But I'm going to try to be optimistic as always, and I'm going to really hope we've got a good workable transformer here, and that it's not another transformer modded onto this terminal board. And if that's the case, if this is a genuine replacement for a MAGNAVOX, maybe it survived the overloads that were caused by these mods, and you know, the overloads that maybe this burning out saved it, you know. But anyway, until next time, y'all be good, and look in on those you love, and take care out there, and we'll see you next time. Brooks Hobby Shop.